Number 15. So now we are looking for exact values of some trig functions. So let's try A. Sine inverse root 3 over 2. So this is equal to theta if and only if root 2 over 3 is equal to sine theta. Oh, can't see it. Okay, this is the only thing I've written. So if we have this, then we have to figure out where does this happen, but we need to know where it is in the domain, because sine inverse is only defined, or it can only output things between minus pi over 2 and pi over 2. So when is sine of theta equal to root 3 over 2 here? We get when theta is equal to pi over 3. And that is our final answer for part A. Alright, so next up is tan inverse of 1. Again, I'm going to set that equal to theta and say that happens if and only if tangent theta equals 1. Alrighty. So that means sine theta over cosine theta is equal to 1, which happens if and only if sine theta equals cosine theta. And where is tangent inverse? What is it allowed to output? Anything between, again, minus pi over 2 and pi over 2. So when are sine theta and cosine theta equal to each other? That happens at pi over 4. And that's our answer there. And that just comes with being comfortable on the unit circle. Now, sine of sine inverse, or arc sine, pi over 3. So here, this one always works out nicely if you have trig function of inverse trig function. You always get that thing back. And let's think about it out loud for a second. Sine inverse of pi over 3. Well, we just did that in part A. That gives you root 3 over 2. But then sine of root 3 over 2 brings you back to pi over 3. So, nothing crazy happening there. D, we have cosine inverse of sine of 5 pi over 4. So here we've mixed and matched a bit. There's a cosine inverse and then a sine. So sine 5 pi over 4 this thing is equal to, on the unit circle, it would be minus root 2 over 2. And now we look at cosine inverse minus root 2 over 2. And remember, so writing this down, cosine inverse is only allowed to spit out stuff between 0 and pi. So it's different from sine inverse in that way. It's minus root 2 over 2. But where does that happen? 0 less than theta less than pi. That's going to happen at theta is 3 pi over 4. And I think a good thing to mention on part D would be, even if this was sine inverse of sine 5 pi over 4, we wouldn't get 5 pi over 4 back, because sine inverse doesn't spit the right thing out. Alright, part E. Now we're dealing with the cosine sine inverse, so trig of inverse trig problems. Cosine of sine inverse of 1/2. So again, sine inverse of 1/2 is equal to theta, if and only if sine theta equals 1/2, but sine of theta is also opposite over hypotenuse. So we draw ourselves a right triangle, call this angle theta, and then 1 can be the opposite, 2 can be the hypotenuse. That's going to make this side, by Pythagorean theorem, square root of 2 squared minus 1 squared, or square root of 3. So cosine of theta, which is what sine inverse is equal to adjacent over hypotenuse, which is equal to square root 3 over 2. Okay, so that's our final answer. Oops, finally one more. We have cosecant of tan inverse now of x. So instead of a number, it's a variable. But again, that's not too much of an issue. Tan inverse x is theta, if and only if tan of theta is equal to x. So we draw a triangle, and we remember what tangent of theta is. This is opposite over adjacent. So we make the thing opposite from theta equal to x, and the adjacent thing equal to 1, because we can write x as x divided by 1. So by Pythagorean theorem, the hypotenuse becomes x squared plus 1 squared, which is 1. And then you take a square root. Okay, so now I want cosecant of that. So cosecant of theta, let's think. Cosecant is 1 divided by sine. So that's going to be hypotenuse over opposite, which is going to be square root x squared plus 1 over x. And that's going to be the final answer there, which gives you the end of problem number 15.